Let's take a look at another example. In 1994, there were 6 million online dial-up accounts on the internet. This amount increased at a rate of approximately 4 million per year until 1997. Because of satellite connections, the number of accounts stayed constant between 1997 and 2008. So the first thing we'd like to try to do is sketch a graph of the situation, and we're going to use t equals 0 for 1994. So we're first going to make tables to represent what's happening here. So if I think about it, at first it looks like we start in 1994, which is our base year, and we know there were 6 million online accounts. So again, 1994 is my base year, that's year 0, and there were 6 million accounts. And so what I'm going to do is use the number and then tack on the million, and so I don't have all the zeros in all of my tables here. So now what we know is this amount is increasing at a rate of approximately 4 million per year. So that means when we get to the next year, year 1, we're going to have 4 more million, so that's 10. Year 2 would be 14, and year 3 would be 18. And that says until 1997. And so remember, this was 1994. So this is 5, 6, there's 1997. So that's the first part of the table. Now, because of satellite connections, the number of accounts stayed constant between 1997 and 2008. So what's going to happen is we're going to keep this number, and then it's going to be also 98, 99, and so on through 2008, and they'll remain constant. And so that means they're going to remain at that 18. And so you'll notice if we do that, there was 1997, there's 98, 99, 2000, 2001, 2, 3, 4, 5, 6, 7, and 8. So this will take us right here to 2008. So now, once we've made our tables, what we can do is we can graph. And again, notice because of the staying constant piece, the two pieces meet. We don't have any open circle. We actually allow ourselves to start right here at the time equals 0, and so we actually have a closed dot. Now, if I were to label, which is probably a good thing to do, I'm going to label my axes, and along the horizontal axis, that's my time. And then if we recall again what we're measuring dial-up accounts for the internet. And so now if we take a look at dial-up accounts for the internet as our output, we'll just put number of accounts, and then we're in millions. You can read my handwriting. Now what I'd like to do is I'd like to determine a piecewise defined function which fits the situation. So notice when I look at the two pieces I have here, both of them are lines. Neither one is going to be terribly difficult to write. Let's take a look and kind of go from there. Now if we take a look at our table, what we did was we developed a table that went from 0 to 3, and so that's going to be my first line. And then the second table went from there up to 14. So what I did was I went 0 to 3, and then I went for t is greater than 3. Now we might argue here that maybe we wanted, instead of this, and we could have a discussion if somebody wanted to, we might want to argue that we wanted to go and stop up through 14 because they didn't give us any more information. So let's take a look at the equations I wrote. The first one's a line with a positive slope, and we knew we were increasing by 4 million accounts a year. So the 4 becomes our slope, and our y-intercept was 6 million. And so when we put that together, we get 6 plus 4t. Notice I used t because that's the variable I was given in the problem. Then once I get to that 3, we were constant. Remember that constant number was 18. And so the equation for the horizontal piece is going to be y equals 18. And so our second piece will actually be f at t is 18. And then notice I just clean up my notation, make sure I have my kind of curvy brace there, and then we're good to go.